Rainfall, drought, temperature levels, and wind speed are all variables in the assessment of climate change. We've been hearing about climate change for quite some time, but what does it really mean? Well, those who should know say it refers to a distinct change in weather patterns over an extended period of time, usually lasting decades or longer. These days, when most people speak of climate change, they're talking about global warming. But climate change is a much broader term that takes into account more than surface temperature increases. Either way, it's a complex science that calls for sophisticated technologies to research, predict, and map a corrective plan where one is needed.
We do two things. So we look at present-day climate. And what we do is we take observations that have been collected by meteorological services across the region. So we look at rainfall, max temperature, minimum temperature. And we do our statistics on them to see how climate has changed already. What we also do is we look at future climate and we run climate change models. And these are just computer models.
To better understand the complex climate system, computer programs have been developed into models that highlight the interactions of climate components. These general circulation models have been used extensively to understand climate shifts, such as this hurricane-like vortices. This model is a projection of the frequency and intensity of a hurricane in the year 2097 between July and August. It will also estimate how hurricanes are projected to change. What this means is, if average weather patterns over an extended period are significantly altered, then it indicates a change in climate change. Other models look at lightning pattern and simulators to help farmers increase their yields while mitigating against excess rain and drought periods.
A number of technologies are used. If we're looking at present-day climate, for example, and the changes that have already occurred, we rely heavily on data from our meteorological centers. So we're looking at technologies behind data collection and storage and dissemination. We also make use of satellite data. It helps us with our observations. When we run these models, we compare them to what we have in our observations to see how well the models are capturing observations. So if it is doing a pretty good job, then we have some confidence that what the model is projecting in the future will be accurate. Another thing we do with our model output is we compare it with other models to see whether there's consistency in the results. Another thing we do is to see whether the output we're seeing corresponds to the kind of science we're expecting from climate change.
A lot of our activities revolve around climate. We know, for example, that at certain times of the year we can expect more rainfall, so we might organize our crop production cycle to align with this flush period.
We are now looking on agriculture and looking on, well, what happens in a drier, warmer climate, how will it affect yields? And we're looking on the study of how that happens. We look on other diseases, we look on the disaster risk reduction in terms of hurricanes, the number of hurricanes, the intensity of hurricanes, what does that mean for shoreline protection?
So why are we going to all this trouble? Because climate change is as much a reality for us as any other country. A look at climatic conditions over the last part of the 20th century revealed some interesting things, like an increase in the frequency of hot days and nights, a decrease in the frequency of cold days and nights, a decrease in the difference between maximum and minimum temperatures, a decline in the maximum number of consecutive dry days, and a slight drying trend in summer rainfall.
Some studies have indicated that our hurricanes would have stronger winds and more rainfall associated with it. Other studies have shown that global sea level will continue to rise, and by extension we expect that for the Caribbean.
This kind of information is useful to the process of governance. The data, if accurate, will help government identify potential and current problems and plan appropriate responses. The climate is ever changing, and that's all good, except when that change brings with it serious danger to life and health. So hats off to those who are doing all they can to map this ever-evolving cycle and the technologies they use to unravel the mysteries of climate change.